Just a second, I start records. You start. We understand that the GIS technology have the major role in technical development. And about strategic landmarks, there are different ways. Firstly, it's a digital platform and different joint solutions and development of infrastructure of GLONASS data and different correction and integrated different sources of geospatial data and resources for integrated as platform, as IT technologies, and as specific program and specific IT solution. Key application for modern GIS are updating digital topographic maps, environmental monitoring, detection and assessment of natural and man-made emergencies, and taking into account the resource of industrial. We understand the major object agriculture or urban and recreation land, building digital models, and area monitoring. The major needs for GIS information support its environmental problem and the dynamic model and operational control for environmental risks and environmental objects. Because very important are building real models and real solutions for forecast of geospatial risks and forecasts real model of risks developments and hazard developments and understanding schedule of bad hazards. And about different ways for solution, it's environmental information for cloud sources and using different IT platform, exploring the dynamic environmental change, graphing charting, and simulation of development the environmental situation, and understanding the results of risks and different geospatial hazards. And about a vector of effects on software technologies. We understand that there are two different and effective ways. The first, the forecasting system through software and network development, and combining individual systems into global remote information and diagnostic centers. And for international and national platform for integrated materials. And one example with solution with results of monitoring atmosphere, hydrosphere, and lithosphere. Current direction of operational geomonitoring. Geospatial monitoring of natural soils, control of industrial and urban facilities, definition of man-made intervention, tourism, power lines, road, landing, and the other. forecasting the situation and planning environmental measures. And key trends. Support for open geospatial consortium standards, because geostandards, it's more important for integrated different data and integration different solution from different IT platform and IT software. And the development of GIS for mobile devices and combining data from different storage and 3D models for analysis tasks. And I'd want to show a few open libraries and open sources. Then we add the material to our team corporative site, and a few days ago, last Wednesday, we celebrated GIS Day, and I'd want to wish new foundation and success for researching and for new geomatic foundation and interesting joint research. Thank you. And then Nekrasov Hlib continue his report about a new project of our team. And Nashon Adero joined our conference.
Sorry, colleagues, because we are in one office. We have some problem with some. Okay, I will share my screen with you and we will start. Today I prepared a brief report for you about two projects which we did last half year. It's not yet done. It's like a test version. And first project is about anthropogenic disturbance of the geological environment in the European part of Russia. And the second one is a dangerous process on the roads of the North Caucasus. Let's talk about structure. Firstly, I should say that we are taking some information from our partners. It's Academy of Science, Academy of Russian Science from Institute of Geography. They are presenting to us SHREP file, which contain a lot of information about location, object, what kind of object, and area around the object. Then we wrote a script which decoding this SHREP file to PDF file, and then PDF file we can apply in our database. In our case, it's Postgres database. As you can see on the screen, here we have SHREP file, and SHREP file contain, in our case, 7 different files. This unique name is one name for one SHREP file, but it can be different shape files. For example, it can be mine. It's the same, can be mine, 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 mine. Each unique name the same here, but it can be different type of shape file, and here unique name can be like crater or something like that, and here can be also crater, 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 and etc. Then let's talk about tools. We're using data grip. We used data grip when we created our database. Shortly, this tool help us to present our project and how we created a database like visualization. But I should say that this tool, unfortunately, is like for each database. PGAdmin in our case is like determine tool just for Postgres, and is like more useful than data grip, because data grip, as I said already, it's like for many databases, and in data grip they're not consolidating their view for one database. In our case, it's PGAdmin, and here we can create a server. I can create our database, see all users who is working with the database or who was working with it. And here we can select a group and say what the group can to do if we will produce frontend, IP, as we did. At least I should say that if we will compare with other databases, for example, with MySQL, here we have simple possibility to create a sequence. It's like we shouldn't find some solution or install something new for our server. We can use this and this in Postgres. We can apply it. It's like default function. At least we created a year diagram. Here we created a database. It's first view, as you can see right now. Here is some information about each ref file, where we have a yellow ID. It's part from ref file. Table many to many, which connect all those tables in database. And we have a division table. This division table select what kind of database it was. Like, as I said, the SHREP file has structure, and this division presenting to user or give to users some possibility to find special information about special object, which he is or she is searching for. At least we used our we used data grip, and in the data grip we visualized our year diagram. At least we have a front end. We using Nginx as engine. We using WordPress, and for draw map and object there we're using Carto. At least we have interface right now. It's just in Russian, but language, but we will improve it in next 2 or 3 months. And you can click on the link. I can send this link in our chat. It's not a problem. For example, if we will click, we will go to website where we can select, for example, close mines or careers. And here we can see all map in European part where we have careers. The same with closing mines. Okay, I will post this link in our Zoom. 1 minute. Yeah, nice.
Get the link to Zoom chat.
Done.
Thank you.
It's first one, and the second. 1 minute. At least we have here some service. We will add some information in the future about project, about members of the project, and about technology methods. At the same time, we will add data monitoring, publications, contact, and this I think is a mistake. We will fix it in a few after some time, but it's like a prototype right now. At least we have the second database. It's like a dangerous process on the road of the North Caucasus. What we have there is, again, we can open it. Here we can see a map with all objects, and here we have landslide, mud low, real, and rockfall. For example, in the future, we are planning to create a monitoring system because it's like normal road in that area in Caucasus. It's like strategic road, which people are using every day approximately to have a connection with Georgia, Armenia, Azerbaijan, and Turkey also. And here, as you can see on the structure, we have here main road, at least here a river, and electrical infrastructure, at least here too, because it's much more easily to build it near to the road, and then if something will happen with it, it wouldn't be a problem to fix it. And what kind of process we will monitoring in the future? I can say it will be maybe in a half year. We will create a drone, maybe not just one. We will create a fleet of drones, and we will monitor all those processes. And after that, we will create a diagram where which will propose to emergency service to use drone with timing when they must use it, with schedule, and we will have a dynamic map of those processes. I'm ready to answer for your question. Please ask me if you have a question.
Colleagues, do you have a question on
Nashon Continuum
solution of him?
with solution of him? Okay, I think, Nashon, can you continue?
I stopped sharing.
Mm-hmm.
Hello,
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 Nashon.
we are glad to see and listen you.
Okay, good. I'm going to present on what we are doing in Kenya, in Africa and Kenya, as far as the development of geospatial databases is concerned. So let me know when you can see the screen. I'm trying to share the screen. So let me know when you can see the screen so that I can continue.
Yes, we can see it.
Yes, so it is about development of geospatial databases. And we are focusing mainly on natural resource research. This is because at our university, Taveta University, and where I am a candidate, PhD candidate, Freiburg University, we focus on resources. We call them University of Resources. And back here home in Kenya, this is where our university is located, southern part of Kenya. And right now I'm presenting from Mombasa. This is the coastal city of Kenya on the Indian Ocean. We brought our students here for summer school, which should have taken place in Germany, but because of COVID, they couldn't go to Germany. So we decided to hold that summer school here locally. We ended today. So this is the county called Taita, and it has a wealth of minerals. It also has the largest national park in the region. And there's also interest in agriculture and conserving forest and water resources. So it is a natural resource management challenge. 1 month ago, the president visited this county and gave priority to geospatial technologies using mapping technologies, also using drones and airborne geophysical surveys to document the mineral wealth of Kenya. You will see that Kenya, in terms of mining, is still developing. Mining is still contributing a low percentage to the GDP, less than 1%, but it is the priority of government to increase this one to 10% by the year 2030. So that is why there's priority being shifted to focus on the natural resource sector, especially mining, which is hugely unexploited. So again, we are using a systems approach as we develop these geospatial databases, because we need to consider mining, forest, agriculture, water resources are related to see the big picture, not just focusing on a linear approach that is treating each sector in isolation. That is not sustainable. So the theoretical approach is to focus on the big picture approach, which we call the systems approach. And this table is showing their differences. So continentally, Africa, we have Africa Mining Vision, and the mining vision is keen on improving the contribution of mining to the development of countries in Africa, Kenya included, because Kenya is an important country when it comes to the mineral called fluorite or fluorspar. It is one of the leading producers in the world. Also, soda ash. So in Africa, we have focus on satellite imagery, and we have produced under Digital Up Africa what is called analysis ready data. And most of this is generated from Sentinel images, 10-meter resolution. In Taita County, which has the University of Mining in Kenya, before this research I'm conducting, we only had a GS database of 11 mines, and this has increased to 53 documented and ready for analysis. We also have what we call mining cadastral portal. This one is assisting the government to harmonize administration of mineral rights in Kenya, focusing on mining blocks and land ownership. I'll show how that one is being processed and the progress on that. We have also mapped our forests using satellite remote sensing. And before that, we were estimating that the forest cover in Kenya was 2%, but through satellite imagery mapping, we documented and discovered that we are now at 6%, and our target is to reach 10%. So we still have 4% more. We have also developed a GS database of roads in Kenya, classes of roads in Kenya, that is under Kenya Roads Board. And now the current project that the government is looking for consultants to deliver on is a national addressing system, to have a national addressing system that can boost e-commerce, can also boost emergency response, including health emergency response such as COVID, by knowing the locations of various offices and buildings and where people live. At Taveta University, where I work, we won a grant just last month from the government of Kenya through a Kenya Space Agency, which is a military arm of government that is focusing on space technology. And under this space research program, which we call Operational Space Weather Research, we have to focus on all these three segments. With the first grant, we are going to focus on the terrestrial segment, where we'll have the telemetry tracking and command station located at our university in the coastal region of Kenya, and two other universities in Kenya that we are collaborating with. Then we'll also have research groups. We'll develop models for early warning systems and for actionable intelligence to support decisions on weather parameters and their importance as far as life on Earth is concerned, and as far as the other sectors such as agriculture are concerned. So you can see that the backbone of this framework is geospatial data. And so as we continue developing geospatial databases, we'll be delivering better from the goal of developing the country and Africa through quality geospatial data. And my experience also by attending many conferences dealing with mining and natural resources across the world has revealed that we need to focus on all these pieces. And if you look at parameters and models, you see we also have GIS data models, or geospatial data information systems data models, which are part of the piece we need to have a systems approach to sustainability, as I showed in the table earlier. So we want to convert data and through science to decisions, because we need to make decisions that are reliable, and the place is key to achieving that goal, hence geospatial data. Remote sensing data types and their characteristics, you can view from this table that we have this guideline. And when you look at this part of environmental risk assessment, there are many benefits we are going to reap from geospatial data, including oil spill monitoring. Like now, I'm just close to the Indian Ocean here, and the risks to aquatic life, such as oil spills, can be very well monitored using geospatial data, remote sensing in the microwave and radar bands. And we are also talking of developing the blue economy in Kenya. So life in the ocean or deep sea exploration are key priorities for the government. We hosted the Blue Economy Conference 2 years ago here in Kenya, and geospatial data is key to informing that. So we also have a geospatial workflow which combines both ground surveys and remote sensing. What we are realizing that we'll have a greater role of semi-structured data because of technological advances in big data, artificial intelligence, and machine learning. And down here, when we are talking of producing or developing decision models, again, we'll need a heavy input of geospatial data to parameterize the models and produce visual maps which can guide our discussions with policymakers, because we need political goodwill. You may be a good scientist, but you still need political goodwill in order to be able to deliver on your goals and impact national development. This is an example of drone imagery in Kenya. I'm happy to report that the government has now come up with a policy and legislation for allowing the use of drones for civilian purposes. And here is a river that floods often in Kenya. It is called River Yala. And through this drone imaging, we can plan better and create 3D models, digital elevation models, for planning how to contain the flooding, which has been a recurrent problem and displacing many people living in this area. And this is high resolution imagery from drone mapping. Again, in Kenya, we are making good use of Sentinel images. You can see for Taita Taveta region, we have good coverage of Sentinel-2 and some section Sentinel-1. And this has really helped us in studying land use changes in this region. I talked of mining cadastral portal in Kenya under Ministry of Mining and Ministry of Petroleum and Mining. You see, we already have a mining cadastral portal, and this is for transparent administration of land rights in the mining regions. And we are using this geographic coordinate system using WGS 84. So when investors are applying for mining permits and licenses, through this portal, they can submit online their request to be given licenses or permits. And this has helped us a lot to harmonize decision making for administration and management of mining rights, which are related to land rights. And this is focusing on this region of Taita Taveta, just as an example. And you can see from this map again how this research, which is geospatial in nature, has improved the knowledge we have about the mining sites in this region. There are 53 in total, and these are the kinds of minerals we have. We also have various rivers and streams that need to be well managed and conserved, the riparian zones. And we have several, we have springs here, and we have 2 lakes within this county. We also have green areas for agricultural production and forests that need to be conserved. Unfortunately, these are some of the activities that are degrading the riparian zones. For example, this is one of the rivers passing near our university, and these are the degrading human activities just within 30 meters from the river bed. So through this kind of research and showing on a map how close these activities are to the riverbed, we are assisting the National Environmental Agency in enforcing the law and creating awareness to improve compliance. So you can see that schematic showing how we are arguing that the local community needs to be involved in the sustainable mining framework. And to involve the local community, you need visual maps that can facilitate communication across various stakeholder groups. So that is the PowerPoint presentation. And finally, if you'd like to see the actual GIS database, which I'm showing here, just let me know if you can see it. I'm sharing now the actual GIS database of the mining sites. Can you see on your side the yellow screen showing the various mines we have, whose databases we have already developed?
Yes, Nash, without any problem, we can see it.
Yeah, now you can see on this one, these are the 53 mines I was talking about. And you can see the attribute table. We have the names and the type of minerals. From there, you can see we have mainly gemstones in this part of the country, gemstones and industrial minerals, such as kaolin, limestone, sand. We also have manganese, which is key to the steel industry. And we have these precious stones such as savarite and ruby. Then we also document the type of licenses. This is for administration of rights. So you can see there are prospecting mines licenses, exploration licenses, mining permits, and mining licenses. So this is what I wanted to show in a brief about the kind of projects we are conducting in Kenya, but mainly through Taita Taveta University, which is the University of Mining and Natural Resource Management, in close collaboration with our partners in Russia, the Expeditious geomonitoring team. Will build more on this. and also bringing Germany on board through Freiburg University of Mining and Technology. That gave me the opportunity during my scholarship there to work on this research to develop a database for mine planning. Thank you for listening, and I'll be glad to get your questions for further discussions. Thank you.
Thank you very much, Nashon, for very interesting presentation about research and development. And I believe that we continue our joint research and our joint project in future about understanding the space weather, really the most completed reasons and different factors for building of clear and atmosphere about sorry, bad connection. But I think we finished about just a second, sorry, I'll try to okay, I tried to normalization of about sound. We understand that the major ways and major vectors of our joint research, and we continue. And I think tomorrow we're talking about new ways and interesting points of our joint research. And colleagues, maybe there are any questions for Nashon?
Nashon, thank you for the report. Are spacecraft helping to explore Kenya's resources? Where do you get the data?
Hello?
Alex, hello? Hello?
So you are asking...
Nashon, do you hear me?
Yeah, I heard you are asking where we get data,
Yes.
from?
Where do you get the data? It's your spacecraft, or maybe it's European spacecraft, maybe US spacecraft.
We are relying on European Space Agency, that is Sentinel sensors for Sentinel imagery, which we can get for free. And we are also sometimes relying on the US, where we have some data types such as the world view, but mainly now the preference is to focus on Digital App Africa, and through Digital App Africa, we are doing our own analysis and corrections to come up with analysis-ready data for the continent so that member countries can use them freely. And Kenya is now, through the Space Weather Grant, there are other universities in Kenya that are working on nano-satellites. So the nano-satellites, we believe, will also help us to improve on acquiring data for environmental monitoring. But we are still at the developmental stage. So as of now, we are still heavily relying on sensors from Europe and the USA.
Okay, thank you.
But how many spacecraft Kenya has?
Kenya.
Are there spacecraft of Kenya?
In Kenya, we had our space station way back in around 1960. That is also in this coastal region, not far from the Indian Ocean, but that was developed through collaboration with Italy. So it is a center for launching satellites. But so far, the services are mainly in the area of communication and weather monitoring satellites, but not for generation of geospatial data, such as the satellite imageries we need for land use planning and land cover assessments. So we still have a big gap in terms of generating the data we need for land cover and land use assessments, town planning. So that area still needs to be developed further, because drones, we'll use drones, but drones can only cover small areas at a high resolution.
Drone is more effective solution, but
Hello, I lost your sound is lost.
Anytime we want to believe that maybe we will build in the long future, we will build new spacecraft pool between Kenya and Russia.
Yes, that will be welcome.
Maybe we will find the way, maybe to have the same project as the students' projects. Well, it shouldn't be a problem, because right now I have seen a map and it's not a problem to visualize it and have the same map which I presented. It's not a big problem.
Yes. Yes, we can help. And maybe in future we organize a new project with data exchange from drones.
Yes, yes.
Why not? If we will use next year drones data of our geomonitoring, I think we will discuss and we will talk about new projects and researchers collaboration and different collaborations for organize a new small project, but then we try to integrate a different solution, different data, and then maybe we will build interesting integrated data and bases maybe in future.
Exactly.
But thank you. Other question, colleagues? Thank you,
question.
You believe so? No question. Okay, colleague, thank you for attention, and Nashon, thank you for very interesting presentation. And tomorrow I think we're talking about articles, but now thank you for students and researchers for discussion and for attention. And good luck for and success, having success of all our geospatial research and geospatial project. Thank you, colleagues. Bye-bye.
Bye-bye. Thank you.
And thank you very much, Nashon. Bye.
Welcome.